Let me just also, okay. It's already recording. Yeah, so let's go over it again. So we requested that you do something, you simulate a logistic population growth curve. So basically what we want you to do, I'm looking for my pen. Okay. Good. So what we want you to do is that if X on the X-axis, which is supposed to be your time, is 0, what should be the value of the L? Not L in principle, but of the Y-axis. That is what should be your f of X. So when f of X reaches maximum, it is 1. That's if you assume L equals to 1. Is it making sense? Am I talking too much rubbish?
Yes, sir.
Okay. So basically, we want you to use this formula. So in principle, you can just bring out your calculator and put, so you force this L to always become 1. So we make L equals to 1 all the time. And then you see 1 plus exponential of K. K is your growth rate. You can look for the growth rate of any bacteria online. Usually, the growth rate is 2 per hour. So you can set your K to be equal to 2. You can, of course, change it because you may be working with another bacteria, for example, or you may be working with a fungi that does not use the same growth rate. So you can say your K is equal to 2. You can see your maximum value that we already set above is equal to 1. And now X naught is this one. So it's where you want this place to be the middle. That is, at what time do you want your curve to reach exactly half? This you can also shift as well. Do you understand what I'm saying?
Yes, sir. Following.
Okay. So assuming, for example, you can, for a start, you can set your X naught to be 5 hours or 5 minutes, depending on, let's just use 5, right? You can put a unit however you want. So imagine that, do you have a calculator somewhere there? I think I have a calculator. It disappeared. I wanted both of them to be side by side. Okay. So let's assume if you have a calculator somewhere around, you can try to punch it for me. But let's assume you have 1. And let's assume you have 1 divided by 1 plus exponential minus K. And in our case is equal to 2 minus 2 into brackets. So we are starting with X equals to 0. Remember, we are starting with X equals to 0 minus X naught. Our X naught in this case is, we said 5. Minus 5. And then you close brackets. So if you try to solve this, 1 divided by 1 plus, sorry, I'm taking you to algebra. It's a lot of mathematics. So you have minus 2. 0 minus 5 is minus 5. So minus 2 minus 5, that's plus 10. So exponential of 10. Then you have 1 divided by 1 plus exponential of 10. What's exponential of 10? Let me look for it online quickly. So it says 22 blah 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 22006. So 1 plus 2 2 0 2 6 point whatever, let's say 0.5. So you now have 1 divided by 2 2 0 2 7.5. And if you now do the calculation of this in the end, so you can say 1 divided by 22027.5. You have almost 0, right? Does it make sense to you?
A little bit, sir. I think it's all this calculation that I want to scatter everything, but I understand the fact that we are supposed to come up with a formula that will be able to
You already have the formula. You don't need to come up with a formula.
the function that would per
That
time give
does
a
this. Yeah.
population.
You have to write a function that does this. So it's like I say, if I say, for example, yes, it's a very simple way to start. Maybe this should have been the way we started. Y equals to x or 2x. Ah, my handwriting is not good. Sorry. But my handwriting is good on paper, right? I hope you know. So let's say y equals to 2x. If you say x equals to 1, what will your y be? Okay, let's start from very simple. If you say x equals to 0, what is y?
0.
0. If you say x equals to 2, huh? Okay, sorry. If you say x equals to 1, what will be your y?
2.
2. If you say x equals to 2, what will be your y?
4.
So it increases in that order, right?
Yes, sir.
8, 10. And that is exactly similar. This is similar to what we just asked you to do. So instead of, this just looks complex. Replace the L.
So I have to write a function that will serve as a calculator.
Exactly.
Okay.
Exactly. It's just because the function is just dedicated to doing this task. Or your calculator is dedicated to doing this task. It cannot do simple addition. It cannot do simple subtraction. It can only generate values for this plot.
Okay.
So you already know your x. Your x, you want it to range from maybe 0 to 10, right? You want your x to range from 0 to 10. But you want to be changing, you want to know what the y is when you change your x. For example, when your x was 0, y was also 0. When your x was 1, y became 2. When your x was 4, was 2, y became 4. So you want to know what happens to y when you change x, assuming every other thing here is constant. Does it make sense?
Yes, sir, it does.
Perfect. Any other person confused about this one? Temilolua, she's decided to go mute on me. Real one, Ogunranti, or really one, sorry. I used to think this name was Read One, but apparently people pronounce it as really one.
Yes, sir.
I can't hear you. Your voice is very, very far off.
Can you hear me now, sir? Good afternoon, sir.
Yeah, oh, it looks like you are like a very, very rich politician, the way you talk. But yeah, go ahead. I couldn't hear you. I still can't hear you clearly, but yeah.
Oh, sorry, it's my network because of where I
Okay.
live. Yeah. So
Go ahead.
I actually joined late, so I was trying to observe what was going on. So you said it is from this formula that means the time we are using is like we have know the time.
Yeah,
Then
you already know the
it
time. You
is
already know the time range.
it is the population density that will be changing
Yeah,
now
yeah,
based on
exactly. Exactly. So the time will change, and when the time changes, the population density will follow suit.
okay, sir.
Yeah.
Okay, sir.
Yeah, so so that's why we wrote it the logistic population growth curve. Oops, what was that? Abisoye and Flourish. I think Flourish already solved it.
Yes, sir.
Yeah. Did this solution make sense to you?
Yes, sir. I get what to do now. It's just like come up with the function. And that's
Exactly.
where I'll come a little battle.
Exactly. Just come up with a function and you can just put in the numbers, that's all. It's a very simple task. It's just because we put the big word, everybody's like, "Hey, what's this?" Okay, Flourish.
Yes, sir. I just joined not quite long.
And
Uh,
for a minute, I was thinking maybe I was in the wrong Zoom call. But I can relate a bit because I use this exponential this thing, what I did. I was one that was asking a question before.
okay. Okay.
But the way I did it, I did not really write it like this, but
No. You don't have
I
to. You don't have to, as long as it works and you can explain it. That's the thing with coding, especially in life sciences. It has to work and you have to understand what you did. Because in the end of the day, if you develop a drug from this logistic function, because for example, let me connect this to drug development. So this is the pattern bacteria use when growing. This is their growth curve in principle. This is how they grow. And if for any reason the growth rate or the growth rate, if for any reason this growth rate remains 0, right, you are going to have a flat growth curve. So if the reason for a flat growth curve is because you added a compound or a chemical compound, the meaning, can anybody interpret the meaning? If you had a compound C and then this compound C turned your growth rate, sorry, not your maximum value, but your growth rate, you turned your maximum growth rate to 0. With C, K equals to 0. Does anybody understand what this means? What this compound is doing? Or what can you call this compound?
it would be an inhibitor.
Yeah. Something that inhibits bacterial growth. What's it called?
Antibacterial. Antibiotic.
Antibiotic, antibacterial. Exactly. So you have to understand in the end, the meaning of you have to be able to put some context. That's what I'm trying to say. It just matters that. So everything we are showing you, we are trying to make you do. It's not because we like complex formulas. No, it's because in the end of the day, you can connect this back to something. So for every parameter here, you understand what they are doing, right? So if I change this to, for example, we change the growth rate to 0 because the compound was added. Now, any compound that can make the growth rate to be 0 is an antibiotic. Fine, that's beautiful. Let's think about another one. What if the compound did not change the growth rate to 0, but the compound, how do I put it now? Okay, the compound did not change the growth rate to 0, but it changed it to, let's say, half. So instead of you having a growth rate of 2, let's say you now had a growth rate of, sorry. Let's say you have a growth rate of half. So this time around, your K is now equal to, let's say, 1. So you cannot reach your maximum value. What can you what can you say about this kind of compound? Let's put context to it. It did not kill it outrightly. That is, it's still growing, but it's not growing perfectly. Anybody has any opinion? I mean, there are multiple answers to this, so you can come up with anything. I am ready. Any opinions?
An enzyme.
Well, you could say, what would this enzyme be doing, for example?
Uh, ah,
Ah,
it's not, like you said, it's not increasing the growth rate to reach its maximum value,
yeah,
but it's doing something, sha.
it's doing something that's not allowing it to reach its maximum potential. Okay, anybody else has an idea before I give you more
Maybe
clues?
We can call it a control agent since it's controlling the growth,
Yeah, it's
the
controlling
maximum value.
exactly. It's controlling the growth rate, and we cannot reach the maximum value. Something is happening.
No idea.
Okay. Let me give you a scenario. So let's consider human beings. And all human beings can breathe in oxygen. And you need to breathe in oxygen before your cells can divide, before you can grow in stature. But for some reason, there are people that don't. Okay, let's think of it this way. Everybody has an average regular height, right? There's an expected height. Everybody. So if you are not of this height, people probably call you a dwarf. Now, this is not to disrespect any dwarf. It's just an example. So let's assume everybody is supposed to reach a specific height. But because this person is special or something happened to this person, they are unable to reach their regular normal human height. What would you say happened to this person? You can think about the genetic level also.
Mutation.
It's a mutation. Perfect. So usually mutations cause reduction in the growth rate also. What other scenario can I think of? Okay, let's think of another one. Sorry, I'm jogging your brain too much. Let's think of another situation where we do not reach the maximum value. We do not reach 1. The growth rate is constant. Take note. But I think this is also hypothetical. I can't really say exactly if this is correct, but you do not reach the maximum growth rate, but you are using the maximum growth rate, but you are not reaching the maximum population height. That is, you are not reaching the maximum value, but you are somewhere stuck in between. You have the regular growth rate. Any ideas? It's a lot of bacterial physiology, so if you don't understand, I get you. So let me give you another analogy. Oh, Ayomide, you have an idea?
No,
Okay.
nothing.
Let's assume, so we are adding a compound. Let's say we're adding a compound also still. So we added a compound, and this compound cannot kill, but it can suppress the population. This is also hypothetical. I should be careful about this, but yeah. What do you think? The compound itself does not kill, but it suppresses the population. Flourish, really one?
Is it like a vaccine?
Vaccine. Well, you could say because the vaccine, no, so the vaccine requires that you should have received it before the infection comes. And if when the infection comes, your body is able to suppress the population, yeah, I think you could say immune system response is fighting it. I think that's also a very good idea. It is actually better than my answer, actually, if I think about it. It's better than my answer. Nice. So my answer would have been, it would still be an antibiotic, but it's an antibiotic that does not kill. Some antibiotics don't really kill, they just inhibit growth. Probably you've heard of bacteriostatic and bactericidal antibiotics. I don't know if anybody has heard about it, but I think relevance answer is better. Yeah. Anyways, that's just trying to put some context to all of the shenanigans of this equation. But I hope you understand, and it helps you to to appreciate how mathematics can contribute to biology. Okay. Any other? Yeah, Ayomide wants to say something.
Oh, yes, sir. It's clearer now.
It's clear now. Cool.
Know what to do now.
Yeah.
Yes, sir.
Okay, sir. So I have the question using Python for this particular part of assignment that I gave us. So will it not require us to like install like the plot for
You
if
do
we have
need
to use Python because
You are not plotting anything. You are not
okay.
doing anything. You are to just give us the numbers. That's what we asked for. If you look at the entire question, there was no plot. There was nothing like, maybe the word curve is what is confusing you, but a curve is not exactly a plot. A curve is just two numbers or two set of numbers, your X and your Y. You don't have to put it on a graph, so to say. Next,
Understand.
next stage, you start talking about curves. Don't worry. You start talking about plots, and you see plotting is really, really fun. Okay. Okay. Any other question before I stop sharing?
All right,
So,
sir. So
yeah, okay, go ahead.
is it concerning the how to go about the code? Like, is it going to be like in one particular? Do I've asked the question personally before? You said it's going to. We might do it in a one particular line, but it can't be one line of code. So, but I don't understand how are we going to
Yeah.
copy our code separately to submit, or I don't
So
understand.
when you say one line, do you mean, because I was also confused by that question, do you mean, okay, I'm coming, let me look for, let's say you write X. I'm trying to write a simple code here. X equals to 2, Y equals to 2. Then your final thing is now like print X plus Y. So let's say this is the function that worked. So are you saying that by one line you mean X equals to 2, Y equals to 2, then print X? I can promise you my handwriting is better than this. X plus Y. Is this what you mean by one line? You are mute. Really one.
Right, sir. All right. No, this is not what time. First function in the assignments, sir.
So I'm asking.
There's still another function. We are writing another function.
Let's say this, okay, let's say this is a function. Let me put def. You are not getting what I'm saying. Because I don't know what you actually meant by. So when you mean one line, do you mean you want to compress all the lines into one line? Or something like this? Because what we expect you to do is exactly what you did in stage 0. It's just copy all the text and put it there. You don't need to compress it into one line or so. Copy all the text and put it there. I mean, do you get my question? You are mute. I can't hear you. I don't know if you are trying to talk. It's not speaking again.
So I think his question is that since we have like 4 different functions that we have to do, it would like everything be in one code. Because what I believe you should do is just like make a comment and do it like function 1, function 2, copy it and submit.
Definitely, you have to submit. Okay, let's say this is function 1. Function 1. everything about, sorry, everything about this is function 1. Function 2, everything about function 2. Function 3, everything about function 3. Just copy everything as it is, right?
Wow.
Copy everything as it is.
That's
Go to
thank you, sir.
manual.
That answered.
Go to
Thank
manage.
you, sir.
No, I'm going to show you everything so that you won't ask me again. Unfortunately, I don't know my password anymore. Okay. Anyways, this is what I mean. Just copy it as it is and go and paste it in there. It will grade. If it's not written clearly like this, it will tell you did not submit a complete set of codes and it will reject it. I hope it's clear now.
Yes, sir, it's clearer now.
Perfect. Okay. What else? Okay, I think every other thing you guys were able to fix. Any other questions? Let me stop sharing. Okay, if there's no other question, then we can round up. I am there something.
Oh, I haven't anything to say. I want to say thank you, sir.
Okay, thank you. You're welcome. Anyways, enjoy the rest of your day and have a wonderful time hacking around biology. So you guys are resuming by May, right?
Yes, sir.
Okay, then we can even give you more tasks. Yeah. Okay. Have a nice day. Bye, everybody.
Bye, sir.